Good morning, everybody.
Good morning.
How you doing?
Good.
All right, welcome to the first MSSC seminar for fall 2018. We're lucky to have a strong testing professional. We've got Andrey Madan from Parasoft, as you can see, lead solution architect, and before that, 10 years at Medtronic.
Yep.
He's here to talk about testing IOT. So, welcome, Andrey.
Thank you. I appreciate everybody coming here. So I will have to start with my introductions. My background is in physics and math. I come from Russia, hence the accent. I've been here since 1999. I also graduated from Purdue University with computer science degrees. Before joining Parasoft, my current employer, I spent 10 years at Medtronic at the firmware development division. Is anybody here from Medtronic? Okay, so you'll keep me honest. I've mostly focused on the areas of firmware development, and the safety critical application development, and especially the area of testing. So I've been a part of the team that created and maintained test environments for firmware testing for implantable devices like pacemakers and defibrillators. So as you will see throughout my talk, I'm very confident with embedded systems, with safety-critical areas of development. At Parasoft, I have a unique position. I've quit doing engineering, so I don't write code anymore. So for the past 5 years, I had actually, I love my job. So I have a really interesting job where I'm in the role to help our clients. So Parasoft, I'll tell you what Parasoft does in a second, but Parasoft, we create tools and solutions to help people test the software. So we automate software testing. So the title is misleading here because I'm actually a pre-sale engineer. So what I do, I go to clients and I explain what our solutions does and also listen to them. So my job is to listen to the customers. And that brings me into a unique position here to talk to you today because I've listened to a lot of customers in mil-aero, in robotics, in financial industry, in medical industry where I'm coming from, and it's very hard and dear to my heart. Also, I have been leading trainings to different customers. So I have a unique blend of experiences that I will be sharing with you today. I live in Maple Grove. I have kids, dog, and a wife. And I like to play soccer, and I'm also starting something with my kids to teach them how to be creative and not follow their own path in life. So that's me. Now, we're all here very serious, and I'd like to kind of lighten up the room a little bit, and I will play a little clip from a YouTube. I thought that on Saturday morning, I'm applauding you guys for waking up and very early on Saturday morning coming here. Personally, I have 3 kids. Yes, Andrey knows what I'm talking about. What are you doing here? So personally, on Saturday mornings, that's the time where my wife and I get some sleep and kids destroy the house. So, but, all right. So have you guys seen this clip before? Some of you had? I can watch that clip like once a day, and I will never get tired of it. I get a laugh every time. So let's just put some things in perspective here before we start the serious talk and watch this 3-minute video.
Yeah, because everything is amazing right now, and nobody's happy. Like, in my lifetime, the changes in the world have been incredible. When I was a kid, we had a rotary phone. We had a phone that you had to stand next to. And you had to dial it. Yeah. You realize how you're making sparks in a phone, and you actually would hate people with zeros in their numbers because it was more like, oh, this guy got 2 zeros. Screw that guy. And then if they called and you wanted the phone would just ring lonely by itself. And then if you wanted money, you had to go in the bank when it was open for like 3 hours. The stand line, wait, someone would check like an idiot. And then when you ran out of money, you just go, well, I can't do any more things now. That's right. You can't do any more. That's it. Yeah, that was it. And even if you had a credit card, the guy would go, oh, can you bring out this whole shunk, and he'd write, yeah, but he has to call the president to see if you have any money. It's all politics. You had to call the president, yeah. It was ridiculous. Yeah.
technology for granted.
Well, yeah, because now we live in an amazing, amazing world, and it's wasted on the crappiest generation of just spoiled idiots that don't care, because this is what people are like now. They got their phone, they're like, it won't. Give it a second. It's going to space. Give it a second to get back from space. Is the speed of I was on an airplane and there was internet, high-speed internet on the airplane. That's the newest thing that I know exists. And I'm sitting on the plane, they go, open up your laptop, you go on the internet, and it's fast, and I'm watching YouTube, but I'm in an airplane. And then it breaks down. And they apologize, the internet's not working. The guy next to me goes, like how quickly the world owes him something he knew existed only 10 seconds ago. Right. And on the plane, flying is the worst one because people come back from flights and they tell you their story. And it's like a horror story. They act like their flight was like a cattle car in the 40s in Germany. That's how bad they make it sound. Right. And like, it was the worst day of my life. First of all, we didn't board for 20 minutes. And then we get on the plane and they made us sit there on the runway for 40 minutes. We had to sit there. Oh, really? What happened next? Did you fly through the air incredibly like a bird? Did you partake in the miracle of human flight, you non-contributing zero? You're flying! It's amazing! Everybody on every plane should just constantly be going, oh my God! Wow! You're flying! You're sitting in a chair in the sky. It doesn't go back alive. And it's shared, really. You know, here's the thing. People like, they say there's delays on flights. Delays, really? New York to California in 5 hours. That used to take 30 years. Once you would die on the way there, and on the baby. You need a whole different group of people by the time you got there. Now you watch a movie and you take a dump in your home.
So I was watching, you were watching the video, I was watching the audience. So it was interesting to see how some of the kind of older people like me would be like, oh yeah, I can relate to the rotary phones, right? And then some of the younger people are like, yeah, they made us sit for 40 minutes, that's a problem, right? So I fly a lot for my job. I do a lot of kind of a consulting kind of arrangements. When we speak with clients trying to understand what the challenges are that are associated with testing. So some of our clients are classified, so I won't be naming any names today because some of our clients have military projects, and I don't think you want to hear a Russian guy talk about American military projects here. But every time I go and talk to clients, I ask the question, why? Why do you need to test? And this video that I played basically shows how quickly the technology is progressing. We are exponentially increasing our ability to deliver value to the customer, deliver something that you value. Like, for example, Alexa, Amazon Alexa. Oh, let's just take my watch, for example, right? So my watch tracks my sleep, and then I can go on my mobile device and see how well I slept, how much I moved, right? So it's exponentially delivering me the value every day, more and more. But yet, that's moving to the direction where now the insurance companies can probably get to that data and rate my insurance rate based on how well I sleep, how much I move, and how healthy I am. So it's moving fast. And normally when something is moving fast, the testing as a discipline is catching up slowly, right? So that's why, so let's just focus on why here. Why is IoT important for us? Because connected devices by itself, it's not fun. Yeah, I connected one thing to another, and it's great that you did it, but why? Why did you do it? So as you see in this diagram here, starting from 1, 2, 3, 4, 4, so you can follow the circle, we first connect the devices. And then, number 6 there, we're actually extracting some value. And the more and more we think about what IoT provides to us, the devices get closer to the human. Like right now, I'm wearing this watch. Somewhere on the floor of a manufacturing facility, a engineer can be there standing, and the robot whacks him with the arm. So, for example, in the operating room, some people are now operating just with a little electronic arm, and then that's how the technology is touching us. Okay, so the idea there is why IoT important? Because it brings value. The consequence of that, it gets closer and closer to the human. And that's where the testing becomes really important. The technology growing at an exponential rate, right? So there are a lot of devices right now on the market, and there's more and more devices that are being produced every day. So if you watch the news, right, we have now wearable devices, we have autonomous cars coming in, we have various medical devices, we have industrial revolution that is coming, and I'll talk about that in a second. So why is testing important? Development is fun. You develop something, you put it on the cloud, and it just works. It responds to your request, it responds to some, let's say, API request, and then it renders the website, and you say, oh, hello world. I can do, let's say, a website in a matter of 10 seconds. I deploy it with Docker and some cloud machine. Boom, it works. It runs. Developing is fun. Developing is easy. When you develop something that is connected to other things, now we're starting to touch human life. And and we're not there yet, actually. So I would argue that IoT testing is very premature. And I have to disappoint you all here who showed up on this Saturday morning that IoT testing is just a regular testing. There is no magic button that I can say, hey, let's test IoT, and it will be very different from everything you knew in the past. Fundamentally, it's the same thing. It's just now the big buzzword, IoT testing. I'm doing IoT testing. No, you're not. You're just doing regular testing. It's just you're applying that knowledge that you've gained from before to testing something that is connected to other things. That's all. So if you're here to learn some magic button, hey, I'm doing IoT testing, boom, it's done, you might as well save yourself some time and go catch some sleep. Any comments, any questions? It's going to be very interactive because for 3 hours, I just don't have enough slides to last us for 3 hours. So we'll have to talk, and we'll have to get to know each other a little bit. Now, let's define some common vocabulary. When we start talking to each other, right? When we start talking within the IoT ecosystem, there has to be common vocabulary. Like right now, I'm talking to you in English, so I'm using the English words. I could have talked to you in Russian, and there's only I think 4 people in the room who would understand me. So the common vocabulary is important because now in the IoT world, it's opening up to whole sorts of different people. There are electrical engineers who develop some sort of a board that then runs some embedded device. That embedded device becomes connected to, let's say, a gateway that is collecting the data, renders the data, and sends it to the cloud. The cloud accumulates the data across multiple gateways and then presents that data via some API to, let's say, third-party vendors, right? So when we talk IoT, let's just understand vocabulary. And I've done some research on this area over the past couple of years. And basically, there's no good definition, so we're going to use one from Gartner. So Gartner defines kind of 3 layers of IoT solution. The first layer is in the red, there is edge. Basically, in the example that I will be giving you, it is an automotive example. Let's say those are the sensors that are, let's say, sensing some movement of the car, or let's say temperature of the engine, or how much fuel left. So those sensors are sensing some data. And then let's just say they're sending those to some hub within the car, and then the car sends it to somewhere else. So that is then IoT becomes an IoT platform. That's next layer of data processing. Once the data has been collected by the sensors, then there is a kind of a middleman, let's call it IoT platform, that collects the data, aggregates the data, and then sends it somewhere else, like to the cloud for storage and for external access by partners. So that's where the enterprise sits. For example, for my Fitbit, I can go on the Fitbit kind of a portal and see all of my data, how much I slept, how much I moved. It builds little nice graphs there. But more importantly, one of the reasons I actually have Fitbit here is not because I want to know how much I move. I want to measure myself against my peers. I want to see if I suck in life or I'm doing pretty good. So I look at what is the average? What is the average sleep, right? I look at what is the average movement. And also sometimes participate in competitions. Like they have this, I don't know, how many of you have Fitbit? Or, yeah, so it's getting there, right? So we can be friends on Fitbit, and then I can challenge you. Hey, I moved, let's say, 12,000 steps a day, and you moved 10. So hey, I can taunt you. That's what they call it. So now it becomes in this space right there. So the Fitbit collected the data from me. Sorry, I'm kind of moving there. Fitbit collected the data from me. Then it sends somewhere to process the data from multiple Fitbits. And now it's exposed me to the value I'm getting. So the end user actually getting the value not from there, but from here. This is why people are building IoT devices, to get to that space, enterprise. OK, so please buckle up, get the popcorn, and then I will tell you what I'm about to tell you. Our talk will have kind of a high-level outline. It will have 3 parts, roughly. I'll do some IoT introduction. We'll cover more details about what IoT means. So Mike invited me here, and Mike said, well, let's just do a talk. And I said, well, what should be the topic? Those are the things I know. And he said, well, let's do the talk from embedded to the cloud. And I'm like, great, Mike, we can fit everybody in the kitchen sink under that topic. We can fit everything. We can hit tanks under this topic. So I sat down and I thought about how can we focus? How can I give you a narrow focus of something that you can take home, take notes, and then learn today? So I reflected back on my experiences with the customers that I dealt with. And I noticed that there are 2 trends, actually 3 trends that I'm seeing. And those are the only 3 that I'm going to cover today. There might be more. That's outside of my kind of expertise. I might be covering something that is not really relevant to what you're doing in IoT. That might be the case. But those are the things I know. Those are the things I've seen real people, real customers use and struggle with. So I look back at 5 years that I've been doing that, pre-sale engineering. And for every customer who I deal with on a regular basis, either I give demonstration of a product, or we're doing a project together where we install our tools and then feed it in the ecosystem, or we're doing some sort of a training or consulting engagement, I create a folder in my hard drive. So I just calculated how many folders I have right before coming here. So I have 170 folders. Yeah, that's roughly my sample size of people I dealt with physically on a regular basis. And also we have calls with customers, 2, 3 calls a week, and we have various conversations. So my value to you is that I've seen what the real industry is struggling with and what people are doing out there in the real life. Okay? So the second bullet here says IoT Edge. We already know what it is. It's the first kind of a phase of IoT data aggregation, data collection ecosystem. It's moving into the safety critical domain. So what does it mean? It means that now companies that have been producing some devices are now being asked to validate and verify those devices for some safety, functional safety specification. OK, so question. How many of you know A standard in functional safety? A standard. OK. So the words 62304, don't ring a bell, 62304, 26262. OK, we'll get introduction into those words, because those are important things. People don't usually test when they don't have to. It's the last thing on their mind. They want to produce cool things. They want things to shine. But then those shiny things are then being purchased by somebody who actually puts that product in the automobile, puts that product in the operating room, puts that product inside a human, and then all of a sudden, you have to worry about certain things. So I see the trend. The second thing I see is, the second thing we're going to talk about here is this one. So we're going to talk about how we're doing embedded testing. I happen to have a lot of experiences in that area. So I'll share with you some of the common characteristics of what you have to do to test an embedded device. Okay? Is that specific to IoT? Absolutely not. Like people at Medtronic, Boston Sci, I don't know, St. Jude, or now Abbott, have been doing medical device development for years. And now we're called, oh, this is an IoT device. No, it's not. It's just an embedded device that is connected somewhere else, just like always. So this topic here, IoT platform and enterprise testing, we will be talking about what are the trends in that other space. And the topic that I will cover in depth is API testing and service virtualization. So we'll cover up how to isolate. The idea there is divide and conquer. You have to isolate the component under test and run some tests on it and make sure that the component is tested in isolation before you start integrating into the overall end-to-end system. Okay? So those are the trends that I'm seeing people struggle with, and I'll tell you what are potential solutions that can exist. Also, I thought about what is unique about testing in IoT. So I'll give you some perspective of what is unique. So I tell you that there is nothing unique in testing on a very fundamental level, but there's some unique trends that I'm seeing mostly related to cultural aspects of IoT development. All right, so dive into this first topic a little bit. So I have a high level, and that's what I'm going to be talking about when talking about testing the edge. I had a customer who come to us and say, we need to validate this device for functional safety. And of course, we tell them, hey, have you done those things? And they said, we kind of have skipped some of that. Well, you have to go back and test it according to some specification. The second thing, so I'm seeing that there's a trend. People, they want to make sure that when the time comes to validate the device for functional safety, they want to be prepared. So they're coming to us and asking, hey, what are the things, the minimal things we have to do today to not be under a lot of pressure when we actually have to do the functional safety certification? So that's a trend, right? The second trend I'm seeing, everybody is now talking about security. So I'll give you some perspective on what can be done, what can realistically be done at the embedded device level with respect to application security. And also, I don't know, how many of you know what CI/CD term means? It's good, because I'll be referring to this phrase a lot during this conversation. So I'm glad that you know what CI/CD. Basically, for all of you who don't know, in retrospect, it's building artifact the second you type the code, integrating it with other components, running the tests, and then eventually integrating that into the role component and deploying it in production, all in a matter of 5 minutes. So that's the kind of an idea. But of course, that has a lot of implications for embedded testing, and I'll tell you some things about that. Any questions here? Any comments? Yeah, let's have it. Let's have an interactive session here.
I have a question.
Yes.
So the three categories, whether it's edge, platform, or enterprise. So when we took like the class here on IoT, we delve into building webhooks.
Okay.
We do some processing of data that we pull from data from the actual sensors, and we kind of aggregate data until something else retrieves that data from them. So would webhook belong to kind of the enterprise segment, or would it be more of the edge?
Where did you store the data?
Well, so in the class, it happened to be on a site, so it was on the internet site. That's the processing outside of the board. But I understand that, you know, from working experience, a lot of times we pull that in and actually do the processing on board level as well too. So it can be at different places. So I don't know if you divide those three categories based on physical constraints, or whether this is a philosophical constraint.
It's a good question. I'll tell you my definition, because I struggle with that a little bit too when I was trying to map the three categories to like automotive example I'm about to give. I was oscillating between two choices, and the problem is right there in the middle. What do you call IoT platform? How IoT platform, how far does it go to the edge, and how far does it go to the enterprise layer? The way I define it in my head, if I'm a third-party system and I'm trying to access the data that you accumulated across multiple devices, I'm touching your enterprise level. Whatever responds to me, maybe it's some sort of a RESTful API that sits there, let's say in the cloud, right, and responds to my requests, that I'm touching enterprise. How deep it goes, I'm guessing the data storage, the business logic that aggregates the data to respond to my third-party request, all of that ecosystem, I don't care where physically it sits. It may be in the cloud. It may be on-premise. That's the enterprise layer that provides value for somebody else. At least that's kind of in my head, logical, right? And then what aggregates data from sensors, that is the edge computing or IoT platform, how you want to call it, right? And somewhere in the middle, it's a gray area. It really depends on how many gateways you have, how complex your ecosystem is. They're just defined it for simplicity. Of course, everything is different. But if you can kind of map it, and I've seen the model where they have 4 things, not 3 stages, but 4 stages. Some European paper define it as 4 stages. So yeah, the middle part is the problem. Make sense?
Yeah. So in regards to application security, how do you see the world of IoT being different than your standard, any other software or engineering kind of group? I know that it's fairly unique, and everybody seems to define it differently, and it's been in the news a lot lately.
Yeah.
What kind of challenges does that bring for you, having a broad base of people you contact, and how are people testing for security in the various ways?
It's a very hot topic. So I'll tell you what I know, and everything outside of it, I will not be telling. So what I know is application security is just a part of it. It's something that you protect your application, but there's also other aspects like protecting the network layer, protecting the data layer. So a lot of layers. There's a perimeter security, there's network security. So let's not touch those layers, right, for now. What I do know about application security is becoming very important, and it's a hot topic. In the IoT device, the difference between your normal application development, yeah, you test for security. But here now, the common weakness becomes exposed a lot. So for example, if I have a chain of devices that are all secure, that are communicating some data, and there is one that has the flaw, my entire chain is compromised. So that is unique about IoT. Now, I'm not talking about one big monolith application that I can kind of secure at the network layer, and I'm done. Now, the data comes across all those layers from one device to another. So it's just enough to penetrate one, and then you get yourself a data backdoor. So that's unique, right? It doesn't matter how well you've tested everything. It matters how well you've tested all of it, right? That's my answer.
I had a question kind of follow up to that. Your last point that you have to test everything seems to be not feasible because the IoT deployment can change drastically in real time as devices come on and offline. So is that really, it sounds to me like the problem you're just talking about is really an architectural problem about architecting these devices to be so closely tied together where if you infect one, you get into the whole network. Is that?
Was there a question somewhere there? It's more like a statement. I agree with the statement, but so, yes. If you reword it in a question.
I kind of wonder, I feel like I understand what you're saying. You can't test all the combination.
Mm-hmm.
But how big of, if you're talking the enterprise level, you're in a factory or somewhere else where they're going to vet all the different components that they have, versus I at home want to have smart things and a bunch of ones. I don't know, I'm just gonna buy what's out there. Like, I'm not gonna, and all the vendors aren't gonna test a combination of them. Like, is it more common than like on the enterprise side to like thoroughly test all of them together before rolling them out?
Yeah, it's not possible, as gentleman there. What's your name? Andrew. Andrey. It's easy for me to remember now. So as Andrew said, it's not feasible to test all your permutations. So they're doing their best. But the question there was, what is unique about IoT with respect to security versus your normal application development? That was the question I was kind of answering. That the unique parts in my case, in my mind, what I'm seeing is there is a lowest common denominator that can be compromised, that compromises the entire thing. That's unique. How we're tested, yes, you're right. It's impossible to test all your permutations. Normally people don't care about, let's say, home automation. Great, you can buy things. It's not really that yet constrained. But for example, Amazon Robotics, they protect their network better than anybody I've seen out there. Even I think CIA protects the network even worse. Well, should. Please erase this.
Follow up with a commenter. So in what I have seen in the IoT world, there's a problem that you don't seem to get with a lot of other types of software or industries, where specifically in security, you kind of have a very fine balance where in order, security has to be up to date. It's a point in time things are secure. So you either have to design for a cycle where you can go and update the security in lots of different distributed systems, which could be all over the world, which inherently you're opening back doors to make it less secure, or you have to rely on a lot of complicated physical means to go and very expensively replace things in the field. How are you seeing people deal with that in the IoT world? It seems like a very complex problem that you don't get with regular software. Regular software, you find a security thing, it takes you fix the security hole, you patch it, you move on.
Right.
This one,
It's a distributed nightmare.
How
Yeah.
are you seeing people handle things?
You know, to be honest, I deal with software testing. So I actually, honestly, I'm not in the room where those conversations are taking place. So I'm just going to plead the fifth, and I don't know. There are things I do know. I'm going to be talking about them on that challenge. This is not where my company plays. We play in the software testing. So yeah, I cannot answer all the questions. But I can probably do a talk on the application security. It's just that piece. We're very familiar with that. So that's what I'm going to cover. Distributed security, challenges associated with updating, patching, various devices that are out there, managing the distribution, all the logistics. Puzzles my mind too. So, yes.
It's more of a statement, but the hard part about security in this model for IoT is because there are so many different layers. So for example, if you know what that particular device, that sensor is doing, you can send fake data and therefore throw off the whole aggregate.
Yes.
But then there's the whole data aggregation part where you can steal the data. So like what he was saying is more like in a home situation, you can now know when people are home or not because your Nest says, oh, I'm going to turn on at this point, I'm going to turn off.
There is no shortage of scares. There's no shortage of it. It's all over the news. It's a buzzword. We can have probably a day's worth of conversation. How many things can go bad? It's what I don't like normally in my life is when people pressure me to do something because, hey, bad things can happen to you. I'm more positive. I'd like to more positive attitude. Let's just do good things in life and test it all the way we can. We do have. I'll show you the link to. We do have one of our evangelists. His name is Arthur Hicken. He maintains the blog called IoT Hall of Shame. And he finds and researches all of the accidents that happen. Sorry, I'm standing like this because the videographer Al told me to stay here. So I'm not walking this way, not because I don't like you guys, but because he told me to do that. Yeah, and then he maintains the blog of all of the accidents in IoT and then monitors that and analyzes that to see if it could be caught with like static analysis, for example. I'm not sure I'm answering your question, but I'm giving you my opinion on that. What's your name? Curtis. Yes, so there was a question there.
I have a question regarding application security. So, an example for the new it's called Apple Watch, which falls under two industries, medical device and consumer electronics. When it comes to a situation like that, do you rely more on the security that's been set by the FDA for medical devices, or do you just go with whatever the consumer industry says?
I'm going to throw it back at you and say, how much do you know what FDA requires the medical device companies to do with respect to medical device security? What is the difference? Yeah.
A lot of regulations and rules, ISOs, things like that.
So the Apple Watch, as far as I know, so there is a, okay, let's start with the classification of medical devices. There is class 1, class 2, and class 3, right? So I would imagine that this medical watch, I don't know if it has been medical device, Apple Watch. I don't know what it does. I'm not a big fan of Apple. What is it?
Fall detection.
Oh, so if I fall, okay. So what happens if it does not detect the fall? What are the consequences of that?
The part that required the FDA certification was they market it for EKG.
It takes arrhythmias or
Arrhythmias?
yeah, arrhythmias.
Yeah, since they want to use the electrocardiogram in their marketing material, they said you have to at least minimally certify it.
Minimally certified, what does that mean?
Is that right?
So,
Okay, I don't know either.
I heard, I guess this is going to be secondhand, but it was like a science podcast that was talking about it, and they said that FDA has a certification for a minimal certification for like, yes, this does something and it's not dangerous. You know, it's not, it's not.
So there's no risk to the patient, right? Yeah, okay. So there is a level of certification. Maybe it's even class 0 or something, not class, between class 1 and 0, 0.5. Yeah. Okay. Well, here's maybe your answer. Yeah, so actually sometimes consumer electronics are protected a lot better than medical devices. And in my opinion, medical devices are very, for the good cause, are very conservative in the adoption of technologies. Consumers, on the other hand, consumer electronic, on the other hand, is very aggressive on adopting all sorts of technologies that are, bleeding edge technologies. And for the good cause, because FDA does not let products on the market without some vetting. So there's less players on the market. In the consumer electronics, it's just a wild, wild west. Whoever first to the market gets the bird. So I'm seeing that there's a lot of consumer electronics is a lot more aggressive industry and a lot more innovative. And sometimes it's less secure, but in many times it's more secure because if there's a bad publicity, it hurts them quite a lot. Because if, let's say 10 people on the market now, one gets bad publicity, the other 9 are winning. Like in a medical device, the situation is a little different. It still hurts, let's say, Medtronic or Boston, but there's less players on the market. That's why. So you can still be on the surface, even if you get hit by bad publicity. Yes?
I just had a follow-up comment to some of the questions about, what people are doing. Well, a lot of the literature, aspirationally says, well, security in an IoT solution is a cross-cutting concern from your edge all the way up to your enterprise layer. And that's, really great. But, focusing on the edge layer, what that could mean, is, if you don't necessarily need, a Linux distribution on your smart object, why put that there? Why create opportunities or vulnerabilities that aren't,
could be prevented by your by your choices of the technologies.
Exactly.
Right, yeah.
And so I was just that was my comment.
Okay.
Just on the edge layer, what I've seen.
Okay, thank you. So this talk is not about security. I'll disappoint most of you probably. This talk is about testing, and testing in the general terms. So we kind of got into security, which I think we should tell Mike. Where's Kevin? We should tell Mike that maybe there's enough interest in the community to do a specific IoT security talk, which this is not it. So there's API testing, IoT platform, and enterprise layers. So we'll cover some of the aspects about API testing. So I happen to know a lot about how properly or not properly test APIs, and what are the challenges that people see in the industry to, let's say, isolate the gateway, isolate some sort of a web service, and test it for future CI/CD integration. Okay? There is this topic here that is interesting. Who should test APIs? It's more of a cultural barrier. When developers develop, they are quick to deliver something to QA organization. Very quick, right? Then QA takes it and verifies according to the requirements. Well, sometimes, and actually a lot of times, requirements are not written, or user stories are not written in terms of the API. The user stories, normally, the ones that QA cares about, are written in terms of the final actions that the users would take. So they're testing the user stories, logically. The developers are developing the product that works. So they care about delivering the code or delivering something that works. The question that a lot of organizations now struggle, and it's not related just specifically to IoT, it's a general problem, is that who should own testing of the APIs? Is it a developer? Yeah, I've given you my stuff. Yeah, it works. Well, have you tested the API? Yeah, I've sort of tested it. And then the QA takes it, and they integrate it. They're testing the overall end-to-end solution. And they're like, yeah, who tested the APIs? Well, I think it works. So that's a gray area in the middle that is right now. A lot of people are struggling with that, defining it. But some people already have some, let's say, API testing initiatives that are successful. So, but that's a question.
Shouldn't it be the creators of the API testing it all out, making sure the blobs you're returning back to your requesters is?
Theoretically, it should, with the only caveat: you hire developers. The second you tell developers you should be testing your stuff, sometimes it doesn't go well. So that's what I noticed. It's more of a cultural thing. You're right. Yeah, logically, if I give you my laptop, I should have made sure that it's all of the buttons are working and all of the plugs are working there. But if I develop this laptop, my mind isn't developing, creating the thing, and I'm giving you my creation. So my mind is not. In order to test, you have to have a tester's mind, right? So you have to set the test ecosystem. So it's a whole different things. Like you have to have the tests, you have to manage the tests, you have to update the tests. So it's just a discipline, right? That it is not the development. Who does it? So.
What do you mean by on their API simulation?
I'll give you an example. I actually have that example somewhere in a slide. So for example, if I develop an API, the example that I will be giving is a car example. So Mercedes now has, or will have, a RESTful API that you can talk to your Mercedes via, let's say, pinging the endpoint. And you can say, lock the door, or unlock the door. You can say, what is my tire pressure? There's some other things that, what is my battery level, charge level? So you can ping the car to tell you some things. So when the car manufacturer releases that API into the wild, the car manufacturer wants that API to be used by other developers. So for example, if I'm developing a mobile app, which is not necessarily Mercedes or Daimler app, if I'm an insurance company, let's say car insurance, or I'm a car dealer, all of those people develop their own little apps to talk to my car. So what Daimler does is they release an API simulator where you can go and pretend that there is a car and then hit my kind of a car, but in a simulated environment, and develop your applications against that simulator. Happens actually a lot right now. Yes?
In that case, the API is like part of the product, right? So there should be presumably user stories directly addressing the API.
It's part of a car, then, yes.
I'm saying like that answers, I think that pretty clearly answers the question with respect to API. Like if it's a public-facing API,
It's a public, yeah.
obviously validation. If it's an internal API, then it's probably incorporated.
Absolutely, you're absolutely right. There is a big difference, and there is some, so MoneyGram, for example, they do have an API that a lot of MoneyGram agents are using to develop their own agent stations. So when you go to Walmart, you're trying to transfer the data, that station has not been developed by MoneyGram, has been verified by MoneyGram, but has not been developed by MoneyGram. So let's say hundreds and hundreds of those stations exist in the wild, then they go against this MoneyGram API, internal API called agent. And then all of the agents now consume that public API. Or it's not really public, but it's been released to the agents. So yes, MoneyGram verifies. Is anybody here from MoneyGram? Oh, too bad. Otherwise, I could. Anyways, so MoneyGram, it's their job to verify that this API works for the agents. Good question.
I have a question on the word DevOps there.
Yes.
I've talked with many colleagues about what that actually means, and a lot of them have said it's a very broad term and it's hard to really define. And for me, I associate it with like infrastructure as code or CI/CD stuff. What do you believe that it is?
It's a good question. We struggle with that definition too. It's not obvious. We call it as a cultural movement. That's how we define it. A cultural movement. It's not the code. It's not infrastructure as code. It's not CI/CD, Jenkins, and Bamboos, and TeamCDs of this world. It's the cultural movement that has been created out of a need. So the question is why? Why there is DevOps? Now, there's a need to bring the solutions that customer or developers code to the market faster. So there is this need, right? So they're shrinking the cycle times, the development and testing cycle times, and there is a need to do something about it. So DevOps is the response to the need to develop things faster and produce and release things faster into the market. So, and as a consequence of that, things like Jenkins are now being very popular. Chef, Puppet, Docker, all of those names, that you find yourself learning when you start talking DevOps are a consequence of a need. Okay?
It's not so much faster, but repeatability.
More robust, yeah. Faster is the key.
Building. You have to be able to rebuild what you built a year ago exactly the way you built it. If you can't, then you failed.
Absolutely. But the driving factor is speed to market. That's what I would argue. But yeah, repeatability is also the key. So if you're not repeatably releasing your code, let's say, into the website or to run the website, if you're not repeatedly doing that, then you're spending time to debug, rolling back your changes, right, to debug what went wrong, and that's your losing time. So I guess repeatability falls in. Yes?
So my name is Hari. So I come from like enterprise application background. So I have a question on testing as it relates to DevOps. For us, a lot of focus is actually on shift left testing. So we kind of move the testing on the left as part of the dev sprints, right? So what kind of trends do you see in IoT? Does it come towards the tail end or does it come?
I will cover that shift left story a little bit. If I don't answer your questions by the end of the 3 hours, 2 hours, then come talk to me. All right, any other questions? Okay. All right, so we covered the introduction. Good. Whew, that was a long introduction. Now, so my professor that I had at Purdue used to say this: every talk, Andrey, should have three parts to it. Every good talk should have 3 parts to it. The part that everybody in the room understands, the part that only people in your area of expertise understand, and the third part is that only you understand. So nobody else. So if you see that in my slides, you have no idea what I'm talking about. That's by design. Don't worry about it. It means I achieved the qualities of a good talk. All right, so there are different areas in IoT that are now emerging. I attend conferences and I hear a lot about smart cities. There's a lot of investments into figuring out how to better lay out the city, how to provide infrastructure for traffic control, for efficient building management. So a lot of that is actually happening, but I don't see a lot of conversation about how we're going to test it, because it's very early right now. It's not that easy to build a new city. Smart energy grid, yeah, those guys are being very active right now. Smart mobility, this is the area that is growing very fast right now. It's the self-driving cars, Ubers, Lyfts. Every manufacturer right now, GM, Toyota, Honda, they're making some sort of partnerships with either self-driving cars or what's more importantly, the data crunchers that are behind that. So for example, Uber is not a car manufacturer, right? What do they do best? They process the data and they give the data back to the consumer. So they're very much a data processing house. They don't own any cars. So now I see that, let's say, what is that? Lyft is in partnership with some manufacturers that actually manufacturing cars so that they can process the data and help them manage their cars, the self-driving cars that they're about to produce, a lot more efficiently. So this is an area that I will be talking about, the smart mobility. I will be giving you a car example. And the area of, smart manufacturing. So I see that those two areas right now, smart manufacturing and smart mobility, they're really focusing on testing the devices, testing the IoT ecosystem with care. It doesn't mean that the rest of the people don't care about the testing yet, but the consequence, people talk to us when they want to test for safety critical, and they want to be very serious about testing. They have testing initiatives. They have some sort of challenges in setting up testing ecosystem in their development organizations. So not that those guys don't exist, but I see a lot of from cars and manufacturing. All right, have you guys heard of the term Industry 4.0? That is a revolution right now that's happening in the industry. They call it the revolution. There's a lot of talks about Industry 4.4. That's a new buzzword. So if anything out of this talk, Industry 4.4 or 4.0 would be a nice term for you to kind of know what it's referring to. It's the fourth industrial revolution of manufacturing technologies. So you can see there, it's like we started at mechanization, something that people stopped doing, and then the machines started doing. And now, all the way to where the cyber-physical systems, as they call it, are now controlling the entire process. Right? So here in computer and automation, you would still have to have people in the loop. Now, with the cyber-physical systems, the entire floor can be run automatically without people. So with that, I'd like to show you a little clip of Amazon Robotics video, which you can find on YouTube. Who knows what Amazon Robotics do? Yeah, kind of. Okay, so in a nutshell, it was a company called Kiwi Motors, or Kiwi Systems. And what they manufactured is little robots like this, like Big Roomba. I'll show you the video, right? And those robots move in the Amazon. All of the packages that you get from Amazon are being shipped from some warehouse, some distribution center. So those robots are doing this. So the robots are bringing the shelves with different products to the outskirts of the warehouse where people pick them up. Right? So before that, people would have to walk on the warehouse and then get the shelves. It's very inefficient. So those robots are highly coordinated machines that are moving the big boxes to see how it lifts and then brings the shelf to the outskirts. And if you notice that there are it's not a sensor, it's like a QR code that those devices, those robots are reading, and this is how they know where they're at in the grid. It's a public knowledge, so Pretty cool stuff.
We saw a video on that company. They had to move from one warehouse to another, so they programmed the robots just to pick up their things, drive
Mhm.
the semi drive to the place they drove it in.
Oh, cool.
The robots just did the whole.
I did not hear that story. But the story that I heard, so now it's, that lady is cute, but we're not here to watch the ladies. This is the Mercedes simulator that I will show you later. So yes, the story that I heard is a lot of times, so first of all, if the manufacturing floor, or if that floor stops, Amazon loses millions of dollars every, let's say, hour, minute, whatever. So it's a big thing. And sometimes the call gets, if those QR codes are being dusty, then the robots cannot read them. So a lot of times, the resolution to the problem is just, hey, go wash the floors, or wipe the floors. So, yes. Yes. Yes, yes, yes. Mm-hmm. Yeah. There's a charging station. And other than the Industrial Revolution, and I gave a little clip of that, the big revolution that's happening right now, and we're seeing a lot of demand for safety critical verification of safety critical parts inside the car, is from autonomous vehicles. I attended the autonomous vehicles conference in Detroit and in San Francisco, and the vision is pretty cool. I was talking to my dad about this vision, and it's a car ownership. This was presentation by, I think that was by Lyft and Magna, if I'm not mistaken. So their vision is to make sure that the car ownership becomes very small. Right now it's very big. And transportation as a server becomes really big, and now it's very small. Now it's like Uber and Lyft, and that's it, and taxis. So they're projecting that we will not be owning cars anymore. We will be subscribing to car as a service. When I was talking to my dad about it, he said, I hate the idea. And I said, I love the idea. I hate owning cars. So there's probably a cultural shift that has to happen for this transition to take place. But I personally love the idea. So out of curiosity, just for me, sorry, I'll get back to your question. Just for me, out of the curiosity, so I can get back to my dad with that, statistics. Out of 50 people we have in the audience, who would not want to own the car and own the service? How many people would want to stop owning the car and own the service? To where you push the button, car comes to you. Okay, so I'll count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we get 20. Okay, so we got 20 out of the 50 on the car. I will be doing some samples of those quick polls throughout the talk, so I'll publish the results to Mike and Molly. There was a first question there. What's your name, by the way? John. Uh-huh.
If we both go to work, we both need 2 cars. So if like it could drive itself home,
Uh-huh.
she drops us off, drops her off,
Ah.
take me, we could go down to 1. Or we live 2 hours from my in-laws. If the 4 of us could share 2 cars instead of have 4, that'd be great.
See, I look at it from the subscription perspective. Sometimes I need a truck. I don't have a truck. But that happens like twice. Well, it happens like twice a year when I need a truck. So I go to Menards and I rent a truck and and the guy comes in with a big paperwork. Have to fill in. Man, I'm losing so much time to get myself a truck. If only I have a subscription service whenever I need a car for myself, like a Mercedes convertible, to take my wife out for a ride, for example. I can push the button and say, I want the Mercedes convertible, and in that configuration, and that car will be available to me in an hour. Or I need a truck, I push the button, and the truck would appear. That would be cool. Yes, you're first. Yes. Oh, now we're talking. I do have 3 kids. My wife works at home, or she stays at home. And I do transport, so they take they take a bus to school. So yeah, I transport them a lot, actually, to gymnastics, to martial arts class. 9, 7, and 1. They do still need it. But are you talking about when the kids will be subscribing?
No, I'm talking about, like, I think a lot of people who talk about saying, oh, we can use the transportation as a service, they don't realize that for a lot of people, like, it's really important to have your car there, because you configure your car to be a certain way. If you put a certain number of cars in it, you have all this crap in your car for your kids.
Oh gosh, we're gonna get into this conversation, I'm sorry, but I would prefer actually to have a very safe way to transport my kids without me driving them around. So on the flip side, I argue that this is a better service for me because I can get my kid, okay, if I know that the car is safe and it's been tested, whatever, I'm comfortable sending my 9-year-old to gymnastics by herself in a car.
But I'm talking about for people who have, like, young children. Like, I know for my brother, every time my brother and his wife come to town with their kids, it's a huge pain in the butt.
Right.
Put the car seats in the kid, like, or put the car seats in the car, and then they drive to their other grandparents.
Yes.
Change them, and it's a huge ordeal.
Then subscription makes total sense. You can subscribe to have a van with, let's say, 7 car seats in there, and it just comes. I'm talking about when my sister and I, we get together, we have 6 kids combined, plus 2 dogs. So. No vans.
But I do have a question. Why would you let the Mercedes convertible if you're not driving? What's the point?
That's exactly the question my dad asked.
What's the point? If you get the Mercedes convertible because it's fast, it's fun to drive, right? But you're not driving. You're driving at the speed limit because it's an automated car, and it's not going to speed for you.
So what is the alternative then? To drive your own, but if you're driving on a highway with the autonomous cars there, you're still stuck under certain regulations, right? So, yes, you're right. And that's the point that I couldn't really process in my head. I told my dad that maybe there will be highways just for yahoos like that, right? They don't have autonomous cars there. You can drive at the speed limit. You can drive stick shift. I drive stick shift, so yes. Question.
What about, like, I mean, if you say that you prefer a subscription, does that include, like, getting rid of all the cars?
Yes. Yes.
What do you do then if you have some kind of emergency and there's 2 feet of snow outside and the subscription service can't send a car to you?
Then what I would do is before the storm hits, I would make sure that I have a car sitting in my garage, which is part of a subscription service that I can subscribe. Maybe there is a snow emergency package that I would buy. Huh? Yeah, so I think we're getting into the rat hole. Yeah. So yes, the question.
Just one of the forms of the service that I actually heard about is that if you already own a car, you can basically sign it up for the service. You go to work, you have priority to go to work at a certain time, and then your car has a job, and it goes and drives off all day. It comes back and picks you up.
That's cool. I'm sure it can be solved. My point is that in my life, I'm only going to live that much long, right? And in my life, there is a considerable amount of time of my personal hours that I spend catering to my stupid car. That's all I'm saying. I don't like it. I hate it. Some people love, taking cars apart and fixing them. I don't like it. So why should I? Okay, so let's move on to the next topic. Speaking of cars, so I created this slide. Now we're getting deeper. Now we're fun is over. Now we're going to talk protocols. Now we're going to talk real testing of real stuff. So I made up this example. So don't think that actually infotainment car runs MQTT broker. So don't think that there is a bare bones only. So sometimes you have RTOS here at this layer. So let's talk about this example a little bit. In this bubble here, in this bubble right there, it's the car. The car has sensors. So in our IoT case, that would be an edge, right? And this yellow box is a hub, controller. And that's where I actually still classify this as an edge computing, right? Because the entire car, in the grand scheme of ecosystem of the IoT, will be classified, in my opinion, as an edge. Okay? Now, The cars will be then, so this layer of the edge, the sensors and controllers will talk via the CAN bus. Who knows what CAN bus is? The problem with CAN bus is that it's not very standard communication protocol. Every manufacturer tends to put their own little spin on definition of CAN. So, huh?
It's also not very secure.
So there are a lot of issues with CAN, but still, it's one of the main buses to communicate between different parts in the car today. So we have to live what we have to live with. Now this CAN bus sends data or events to the hub. The hub processes that with some sort of a controller and then publishes certain events internally to inside the hub ecosystem with MQTT. So MQTT is just one of the protocols I took. It doesn't mean that the cars actually do have MQTT broker in there. And the infotainment system, when you push the buttons and press the buttons, has the user interface. Then this other hub, infotainment system, it has maybe running some sort of a server, not maybe, for sure, running some sort of a server that can respond to REST calls from the outside, and it can also send events to either nearby cars or nearby infrastructure. So V2V stands for vehicle to vehicle. V2X stands for vehicle to something else, like a traffic light, or maybe a parking garage. So you were talking to me about the parking garage, right? So that would be V2X communication, where a car pulls in, says, OK, I need a spot, and then all of a sudden you take your hands off the wheel, and the car will just drive to an open spot by itself. That would be cool. Does it happen? In the future. I would love it. I'm not a very smart person, actually, so I'd like the technology to do things for me as much as possible. Yes?
Because you're adding another layer of hardware, software in this ecosystem, are you finding that your test cycles are now longer? Is there more pressure to have your test cycles longer, or is software automation somehow, being able to press your test cycle from like 4 weeks to 2 weeks because of automation comment?
Yeah, so there's really nothing unique about IoT, right? We're still talking about a classical testing problem, right? So we're just introducing more protocols. We're introducing more players, more stuff. So that more stuff, the rule of the game is divide and conquer, and that is the topic of my talk, actually. I'll talk about that in a little bit. If you want to speed up, you have to parallelize. The problem is that the more stuff you have, just like in a classical parallel computing problem, the more processors you have processing your problem, there is a point where adding yet another processor will not speed up the overall processing, right? So it's just the same problem. With the two things, yes, if you parallelize the testing of, let's say, the sensor part and the infotainment part, yes, you gain certain speed. But if you have, let's say, 100 things, and then you're testing, you still have to test them in parallel, but then you actually end up spending time integrating those pieces together. So the overall time will be bigger.
I think you also said, too, that we have that in terms of the testing theories, the best practices, the methodologies that are available to us today is enough to get us through good testing for the IoT embedded systems. All the tools are available today to verify that IoT matches the specification.
I believe so.
Okay, so there's no missing theories, no missing methodologies that we're all groping for as an industry to fill that void.
Yes, with one exception. There is now this trend called artificial intelligence, or AI, machine learning. So minus the machine learning, that have to be tested to be correct. But how do you test AI, right?
That's a current test hole in the industry today.
Right. So other than that, I'd say that the statement is accurate, to the best of my knowledge. Somebody can argue against it, I would. Yes? Andrey.
So the edge devices are essentially just computers, so I think we already know how to test them, right? So is IoT testing really just about testing the system of devices connected together only? Or are you considering testing the devices part?
Yes, I'm considering testing devices part of it too. Yes, and I will be talking about that. Because this testing of the device is nothing unique. We've done it a lot of times. There is one caveat that I want to bring up today, is that now you have to think about the device can be potentially used in a safety critical environment. So when you're creating IoT device, sometimes you don't think about, oh, this particular vision sensor is now just part of my home, let's say, ecosystem. But that same vision sensor can then be put on a car and become a part of a safety critical ecosystem. And the rules that are applying to developing software for safety critical, let's say, devices are slightly different. So I will be covering that today.
So safety critical, but we already know how to do safety, life sciences software, Medtronic, right?
Right, yeah.
They've done it for the last how many decades, right?
We know.
Well, same principles can be applied to automotive, right?
Oh, they are.
You think it can be just...
There's the two ISO2626 standard.
Those developers in that industry to accept and acknowledge those principles that was learned in the Medtronic industry and carried over to the automotive industry.
I think there's a big difference there. Where in those cases, the system is developed, the total system is defined and developed up front and tested as a whole. In the Internet of Things, you can add and remove to the system. Anybody can change the logic. And there's a company, Comma.ai, where you can plug in something to your CAN bus and add automation to your car. I mean, are they responsible for making sure every car they plug that into?
It's a philosophical conversation, right? But I want to address, what's your name? Scott.
But the thing is, I think you lose control over your system of your you arbitrarily plug in devices and you lose control over the safety of your system or your warranty to the end customer of the safety.
Yes. There are technical aspects and there are actually marketing or money aspects of things. So when you sell, let's just say that you're a startup, okay? Let's just go with that. You're a startup, you develop a vision sensor. That's actually a real situation. That vision sensor, you originally developed it with certain things like coding standards or unit testing methodology. So all of the things that you would do for a medical device company to start with, following the V diagram and whatnot, right? We're not there. They just did it the best way possible. But then they have to go back and align all of the testing that they've done to satisfy the seller or the buyer. Now there's a tier 1 manufacturer comes in and say, I want to buy your device, but I want to put that device into the car. Well, there's certain documentation that you have to show, and they didn't have it. And there's a business implication of that. So I agree that, yeah, you can put a lot of things in the CAN bus to hang off the CAN bus, inject events, monitor traffic. I agree with that. But what I'm talking about is a different spin on things. It's what happens in the real life. And in the real life, people sell startups to other companies, and they have to think about how they sell their IoT ecosystem to other people, how they present that. That's my point, right? So I just want to make clear. Yes?
So basically you're talking about like trying to get out in front of the fact that a lot of startups will have a business opportunity, and then the person will say, you don't have the documentation I need, you're not meeting the qualifications and specifications in terms of safety. So
right.
You're trying to help them get out in front of that.
Yeah. That's the topic of it. Maybe there's other topics in this talk that we can invent, but that's kind of the area that I thought, what is so special about IoT? What am I seeing out there? What is that I can bring to the table and tell you, yeah, those are the real things that are happening. That's my job here right now to kind of do this. Yeah, Andy, you were shaking your head.
Well, it's just, I think there's two cases we have to handle. I think one is if one company and one entity owns the whole IoT, that domain,
right.
Then they can, in theory, test all the combinations of devices. But if somebody owns the platform and sells that, somebody owns the devices and sells that, and it's the end customer that combines them. Who's responsible for making sure that?
Yes.
That
on customers.
So, like, if I do that at my house, that's, I guess, what I'm asking is, like, is testing going to cover that? Do we have a methodology for testing that type of scenario?
Like that type of scenario of overall end-to-end?
Yeah.
Okay, I'll get to it. Actually, I have some ideas that I can bring to the table, yes. There was a question there.
Yeah, so this is kind of not really related to that, but I was wondering, how is the car connected to the internet? Is it through like a cell tower, like radio waves, or through satellite, and who's paying for that service? So if you have a car that has, they had like a commercial for Ford trucks, now you can have Wi-Fi in your truck. So how is that service being paid for? Does the customer pay for that? And is the car connected to a satellite, or is it connected to a nearby radio tower?
It's connected right now, from what I know, via the satellite towers. Or when this type of communication, there is actually, I think I do have a slide somewhere, because I was thinking about the same thing, right? Somewhere I do have, yes. So this is the slide that sort of talks about all layers of communication here. So you basically pick where you're at. So Bluetooth, Wi-Fi. The thing about cars, it's moving, right? So it's not stable. So it has to connect to via the cell tower, something that is stable. If it talks to other cars, it's normally like a near. I forgot what it is, but it's not Bluetooth, but it's kind of a low power. It's a near field NFC, yes, NFC. So near field communication.
So my company actually deals a lot with that. They're in full talks about 5G, which is the smart city, smart cars, power deployments. Basically the same thing as 4G, but on a much smaller scale, so it can fit more data through it.
Okay.
That's how they just.
What is the company?
So it's Comscope. And we basically sell the antennas to AT&T, Verizon, all your big providers, and then your car would have the same kind of service that your cell phone would, and it'd just be a contracted deal.
Okay, thank you. Because I was about to say that I have no idea who's going to pay for it.
I kind of talked a little bit about that from what I've been seeing over the past year. There's no standard, but a lot of companies are experimenting in. A car is a big purchase. They get money away. It's become really powerful to have a subscription service to a different kind where you constantly get money. So what a lot of companies are doing is they're finding a way to bundle a lot of cellular service together and just sell you you have Wi-Fi in your car as a service. So you're paying for that on a subscription. Like you get a car with Sirius radio, you pay for a subscription fee. You're paying to somebody there managing all the costs on the back end for the cellular connection and charging you trying to make it. So that's kind of the most common thing that I've been seeing is
Was there a question there or comment?
Comment. While the side discussions are interesting, could we return the topic to concepts and approaches to testing?
Yes. Thank you for getting us on track. Okay, so I'm going to be getting to... Okay, so where did I stop? Okay. All right, so throughout this talk, I will be talking about the testing of this ecosystem. So this is an example for today's talk. And we're going to be getting more and more familiar how to test at the lower level, then how to test components, and then how to test the entire end-to-end scenario. Okay? So we already have seen it. Gartner also defined some layers on the IoT. In the interest of time, I think we're just going to go into, okay, so there's some trends that we're seeing in the testing, IoT testing. So what is unique, right? The next thing we're about to discuss is moving into safety critical domain, what are the things that you can do to protect yourself to future-proof your application. We're going to be talking about interoperability and API testing. So those are the things that people tell me. It's like, okay, do you have a solution? When we test the end-to-end scenario, where does the failure occur? That's a very common problem right now, that if you start putting the things together, and more things you put together, then you end up not knowing which of the stages, is it the edge, is it the IoT platforms, is it the enterprise level that had a bug. So that's a problem, right? So who knows about the test pyramid? Now we're getting into the topic of actual testing. Who's familiar with the testing? Nobody's familiar with the testing pyramid? Okay. Huh? Okay, so in Martin Fowler, rings a bell? You probably have seen this before. Okay, oh, sorry, yeah. Whew. So that's a classical testing pyramid that has been introduced by Mike Cohen, and it's also applicable in IoT testing as well. So now we're going to peel up the onion. We have about an hour and a half, and dive deeper into the technologies. Building a solid testing pyramid in IoT is important because, as I said, one of the big challenges is once you start testing end-to-end, you don't know where the failure occurs. So you want to get as much bugs or issues out of the components by testing at the component level, by testing as early as possible. Somebody mentioned the word shift left. It's also, yes, it's also applicable in IoT. So now we're talking about the testing concepts. You want to start, so a lot of people just start with GUI and automated testing at the very top. By the way, I do have a question. In this class, do you guys have a class on just software testing? I know that. Okay. And have you covered this in a class? Or concepts?
Not a lot of the automated testing. I think it was the concepts of what to test and.
Okay. Okay.
Right.
So automated tests. The reason this pyramid has been created, because the lower you go on the testing pyramid, the lower you go, the easier it is to automate it, right? So if you have a unit test, let's say JUnit or CPP unit, or let's say some sort of a unit test from a custom framework that you've created, it's easier to automate because there's less dependencies that you have to stand up for the unit test to run. All you have is maybe a CPU simulator, and that's it. Whereas the higher you go, the harder it is to automate because you are now have to provision a lot of backend services and a lot of ecosystem to make testing possible. Hence the pyramid, the lower you go, you have to kind of create more stable tasks that you run every day with your CI/CD tool. And then the higher level tests, hopefully, will reduce in size. That doesn't really happen in the industry, to be honest. A lot of organizations I talk to, this testing pyramid looks like an ice cream cone. So a lot of people have a lot of system level tests, not a whole lot of middle API level tests, and a whole bunch of unit tests if they're disciplined about it, right? So that pyramid looks like this, like a little what is it? Yes. So let's talk about embedded testing. How many people here can code in C? Okay. That's good. So when we get to C level, so in the continuous testing pipeline, when we put all of those parts of testing into the CI/CD pipeline, we run them in sequence. So first, you run your build, right, somewhere there. You run your build. You check in the code, right? You run the build. And then you run whatever you can run. Either it's a static analysis or unit testing. You collect some sort of code coverage from unit testing. And then you publish the results. And sometimes the build fails. Sometimes something else fails, like static analysis tool produces some violations, so you have to look at them. Code review fails, so your peer said, nope, it's not going to be pushed to the next level. So this is where we're at today. We are going to talk about this blue piece, the first stage. We are going to be talking about various practices that are applicable in this phase. Again, does it have anything to do with IoT? All right, quick poll. Who knows what shift left is? you apparently know. So there's a big, I would say, industry movement to shift left all of your testing practices. Everybody would tell you, hey, you need to shift left. You need to start testing earlier. But the truth is that, so this is the story. Everybody realizes that in order for you to reduce the amount of money spent on a defect resolution, you have to catch it earlier. But I would argue that it's a nice story, but it doesn't actually work in real life. The reason it doesn't work, or at least to my knowledge it doesn't really work well, is the amount of bugs you can catch at the unit test level is, let's say, this big, right? At the unit test, you're testing what? What do you test at the unit level? You test logic, right? You test the logical transitions that your code take throughout the, while it's being executed. What do you test with static analysis? You do test the patterns, right, that the way the code is constructed. But you don't test the interactions between the components. And that's where most of the bugs actually are. So yes, there is a nice story about shift left, but in practice, it's applicable, but I would say that it's not really. It's a nice story, but that's where it ends. Okay, so I had to think about what can I bring to the table when I do this talk. So since I'm very familiar with functional safety standards, I will be telling you some of the best practices, how to future-proof your application to be compliant with certain functional safety standards. How is it related to IoT? When you produce C, C++, or Java, or .NET code, mostly C actually, there are some things that you can do without much effort to future-proof your application to be compliant with safety standards. I had a real use case in the automotive market that I already mentioned here, that the vision sensor was developed to be used and tested as a prototype. Then this company was sold to a tier 1 automotive manufacturer. That manufacturer required ISO2626 compliance. And that's where they asked the question, okay, how quickly we can get our device, the hardware, the firmware, the APIs, the entire ecosystem to be compliant with that standard? That question is applicable to IoT, in my opinion. Okay? So what do you think the answer is? What do you think the answer that I gave them? Very close, very close. I was a little bit more aggressive. Okay, any other guesses? By the way, who is familiar with ISO 26262? Who knows what we're talking about? Yes, a gentleman there, one out of 50. Okay, I'll write it down. This is interesting, right? For me, at least. So what I told them is they're screwed. And I said that because that's how I feel. They're screwed. And then everybody in the room laughed except the manager. So when we start thinking about how to test things for safety critical industries, this ISO 26262 defines some safety levels. So let's say a device can be classified as A seal as a safety integrity level, certain level that it can either kill the person or be hazardous to the environment, right? So depending on the risk associated with this particular part of the system not being not acting as it should, depending on the risk, it's been classified. So the cost of compliance rises exponentially. So I think this slide used to have 100x. So every time you go from A to B, from B to C, from C to D, the cost of compliance rises like 100x. So if you spend 100 hours on a class A, expect to spend 1,000 or actually 10,000 hours on a class B and so on. Okay? Who is familiar with the V diagram? Okay, now we're getting into the domain of where I'm comfortable with, which is the safety critical. And so here we're first going to be, we're going to be talking about the code level. So what can we do in the software testing to start testing the code as soon as you typed it, as soon as you compile it. What can we do? And the ISO2626 document describes what you should do. And that's one of the actually rare cases in those documents that the document has a specific coding standard in it. If you're familiar with 62304, which is a medical device, IEC61508, it doesn't really tell you what coding standards you have to use. Whereas this document refers specifically to MISRA-C. Who knows what MISRA-C is? It's a coding standard, which is developed for automotive industry, but it's very noisy, and I'll cover that later. Okay? Aha, now we're going to have another quick poll. So MISRA-C, we already know. Who knows other coding standards? Like, can you just name, because I have a list of, I don't know, 13, 12 coding standards that are listed on this page. Other than MISRA-C, do we know any other standards in the room, like coding standards? Yes? Which one? JSF, right? Yes, it's on the list. Giant Strike Fighter for F-35 program. Anything else? So JSF, good. All right, so you'll actually learn something today, which is great. MISRA-C 2012 is one of the most common standards in the industry right now. Everybody knows it. Cert-C for C++ and Java, it is a standard to cover, guess what? Security. It's a with the security for JSF. UL2900, it's the medical device. Altazar, CW Sans, High Integrity C++, MISR C++ 2008, OWASP Top 10, bar group coding standard. Have you heard of bar group? Okay. Effective C++ by Scott Myers, and Power of 10. And there's probably others that I didn't list here. But you see that the list is kind of long. And all of them think that they got it, they nailed it. They know exactly what is the subset of a C language or C++ language that you have to use to make your application robust and secure. All right, now we're getting into the weeds of the topic here. This is the area that probably not many of you are familiar with, but if you want to be compliant or you want to run static analysis, you will quickly find yourself in a situation that if you run MISRA-C rule set, so who ran MISRA-C on their code base? What did you experience?
Do it from day one or you're dead.
Okay, but let's say you run it on a legacy code base of, let's say, 10,000 lines of code.
If you try to apply it to a legacy code base, it's a huge rework.
Yeah.
It's basically rewriting your code from scratch.
Yes.
With an example of what it's supposed to do again.
Yes. And I hear that every day. Like I talk to our customers and I hear that same story every day. MISRA is very noisy. And so what you're seeing here on the screen is the couple of things that the MISRA consortium did to address that very point. They introduced the notion of a compliance. What does it mean to be compliant with MISRA standard? And they created this document, MISRA-C 2016 document, that outlined, okay, in order to be compliant, you have to have four documents created. There is an enforcement plan, recategorization plan, deviations report, and guidelines compliance summary. So if you run your document, and then you reclassify it a certain way, and then you create a deviation report, like suppression report, for all of the suppressions of, there is a mandatory, required, and advisory, of everything but mandatory, then you can claim compliance, right? So they gave you a framework in which you can talk with people, normal people like you and I, that you shouldn't really fix everything that the stupid tool tells you to fix. So that's a problem, and they're trying to address it. They're still not there yet, but at least that's the first step to address the problem.
What I found interesting going through the MISRA guidelines, there's actually a note, as part of the guidelines, from the group that developed it. Their big takeaway was, don't use C. Go with a Ada or something, or any other language that you can.
There is nothing.
It never.
So in we thought about it, right? We thought that C++ is where people are going to go. The reality is that we, as a tool vendor, right? I work for Parasoft, right? We have to know where to invest the money. So right now, if let's say out of the 10 conversations with people who make embedded systems, 9 of them use C. And it's not going away. So bad news. Well, not bad news, but that's the most useful. That language is still used, and it's growing in popularity. Why is it growing in popularity? I can have another talk on that. Okay? So, long story short, for all of you who don't know what we're talking about here, yes?
The 3-hour-long session.
I don't know. Who is running the show here? Oh, me? Are we supposed to? This is the first time I'm doing it.
Let's do a 10-minute break.
Is that okay?
Yes.
Okay, we'll start the session in 10 to 10.